Hello friends, welcome to my YouTube channel. Today we will learn about sparse matrix and we will write a C program to represent a sparse matrix to convert a normal matrix into a sparse matrix when in a normal matrix the non-zero element is very few than its size, then it takes too much space. Okay, now you can see here a matrix of 5 into 4 is given. The size of matrix becomes 20, but the non-zero element is only 4. So for 4 elements, we have consumed 20 spaces or 20 space element. But we have to write only 4 elements. We will use only 4 elements because non-zero elements is only 4. So to consume in order to consume less space, we convert into sparse matrix. In a sparse matrix, we just only write the non-zero element of the matrix. A sparse matrix you can see in the screen right side. This is sparse matrix. In the sparse matrix, this is the colored row is called header row of the sparse matrix. In this header row, we write the information, some information of its normal matrix, such like in the 0th column we write the total number of rows in its original matrix. In the 1th column we write the total number of columns in the normal matrix, and in the 2th column we write the total number of non-zero elements of its normal matrix. Okay, and from row number 1 to rest of the row, okay, to the rest of the row we will write the element and its position from the original matrix. Suppose here in the row number 0 and column number 1 the non-zero element is 2. That's why in the row column in the sparse matrix we have written 0 for the 2th element in the normal matrix, which is also in the 0th position. That's why we have written 0 in the row column of the sparse matrix. Okay, now the non-zero element 2 is in the column number 1 in the normal matrix. That's why in the column we have written 1 for the non-zero element 2, and in the 0 number row and 1 number column, what non-zero element is here? It is 2. That's why we have written here 2, and so on. We can easily write its program to convert a normal matrix into its sparse matrix. Okay, now come to the code. First of all, we will write header file as include stdui.h. Include console.i.h and has include stdlib.h. And one thing I want to say you, we will use dynamic memory allocation here. Okay, because in the static memory allocation we have to define the array size at the beginning of the program. Okay, so that is and we will here use dynamic memory allocation. Okay, so now first of all we write a function to convert a original matrix into its sparse matrix. Okay, so now we write main function our main function first, int main. Okay, pointer variable a, in which we will contain our original matrix. Okay, and another pointer variable sp, in which we will contain our sparse matrix. And I comma j is for iteration. First of all, we will take input. Here we have taken the input, enter number of rows and column respectively to the row and column variables. Now, as we have taken the row and column, we can now have the size of the matrix. So we have to allocate the space for this. That's why we have allocate. Now we are allocating the memory using the Kalam function. Now to take the array elements, array input, So friends, we have taken the array input, okay, which will store in the variable a. Now to convert it into the sparse matrix, we call a function original to sparse. In this, we send the argument as a, number of row, number of column, and the sparse matrix that will contain in that contains the non-zero elements of the a. See this function calling statement carefully. Here we call a function called original to sparse. We send the argument as the original matrix A, number of row, number of column, okay, and the sparse matrix that will be created will store in this, okay. So for this we have to write a function. So now be writing a function. See friends, here we have sent the original matrix A by call by value. That's why we have just put here the double star and the variable sp as call by reference. That's why we have put here triple star. So now we will write the function. First of all, we take some basic variable. We take some basic variable declaration. Here INJ4 is for the iteration. K equals to 0 we have taken for counting the total number of non-zero element in the original matrix, and x equals to 1 is for storing the non-zero element of the original matrix from the row number 1 from the sparse matrix, because in the row number 0 we have to write the header. It is called header row. We have to put here the information of the normal matrix. So and alloc is for allocating the space, and double star p is the pointer variable that contains the sparse matrix, okay. So first of all we declare its size. Friends, let's see here. First we have allocate the memory dynamically. Then here listen, this is for printing the this is for allocating the memory for the rows, this is for the columns. Here we have allocate 3 columns, because in the sparse matrix we have just only 3 columns. First is for containing the row number, second is for column number, and third is for storing the element, in fact non-zero element. Okay, that's why we have allocating just three columns, each of size int. Okay, here we will go through um, the mat from the row from row to column of the original matrix. Here we are checking if a of I and j is not equals to 0. That is, we are checking the array element is not 0. It means it is, if it is non-zero element, that then only it will be stored in the sparse matrix. That's why if the current array index of the original matrix is a non-zero element, then its row, that is I, will be allocated in the row. Current row is of x is 1, means it will be stored in the row, and 0th column means we can store here in any row, but in the first column only we have to store the row number. Similarly, in the 1th column we have to store the column number, that is j, and in the 2th column we have to store the array element, that is array element. Similarly, simply, and k plus plus is for counting how many non-zero elements are there present, and and the result will be stored in the here 0 2, row 0 column 2 of the sparse matrix. Okay, so we store it sp sparse matrix 0 column 0 row 0 column equals to what? Total number of row, that is row. Sp of 0 1 contains what? The total number of column, and sp of 0 and 2 will be equals to k. And okay, and to link this sp to this sp1, we have to write star of sp1 equals to sp. Okay, so friends, we have already a function written here. We are just copy and pasting this. Listen, void display original. This function is for displaying the original matrix. Okay, and void display sparse is for displaying the sparse matrix. Here what we do is sparse matrix will display from 0 row and 0 column up to total number of elements column to 3, sorry, total number of elements row to 3 column, and print, then further will be it will be printed. Okay, so let also here we call the function display original a, and also display sparse, that is sp. Let here give the Okay friends, so we have completed our program. So now let us compile it. Okay, now we are taking the input for row, for column. So friends, you can see here our original matrix was here. So this is our original matrix and this is our sparse matrix. We have successfully created this.